Mine is showing up. Okay. So, at the top here, did you save it? Did you save it, or is it also? Cleaning. You're just cleaning it. Freshening, airing it up. Okay. Log base 2 of 2 is what? 1. 2 to what power is 4? 2. 2 to what power is 8?
3.
2 to what power is 16?
4, 6, 7, 8.
5. 2 to what power is 64? 6. 2 to the 7 is 128. 2 to the 8 is 256. So remember, that's what your calculator is doing whenever it's calculating this. Yes? It's a lot harder, though, if it's like 2 to the 5, because then it's 2 point something, right? We just don't know what that something is. So we're going to look at these. So if I have log base 2 of 4 plus log base 2 of 8, log base 2 of 4 is 2, plus log base 2 of 8 is 3, and I get 5, correct? True? We can also put these together using the sum and product rules. So if you look up here, if I have 2 logs with the same base and plus 1s in front, I can put them together by multiplication. So let's look at this one. I have a plus 1 in front, a plus 1 in front, a base 2 and a base 2. Do you see that? So then I can put them together as one single logarithm by going log base 2, and then because they have plus 1s in front, I multiply them. 4 times 8, which is actually log base 2 of 32, which equals what? 5. Okay? This next one, log base 2 of 2 is what? 1 plus log base 2 of what is 32? So I should get an answer of 6. Can I put them together? They're both base 2, and I have plus 1s in front. So can I put them together? Yes. So I put it together as a single logarithm. I get log base 2. And if they have plus 1s in front, I multiply them. So I get 2 times 32, which equals log base 2 of 64. And we found out that that was 6 above, right? So we can do them separately, but we can also put them together through multiplication. And we have to know that because it's not all just going to be numbers, it'll be variables. You do 3 and 4. Go. Log base 2 of 8 is 3, plus log base 2 of 16 is 4, which gives me 7. And then because they have plus 1s in front and they're both log base 2, I can go log base 2 of 8 times 16, which equals log base 2 of what? 128, which equals 7. So it just shows that we can actually put them together that way. Dora. Then here I have 5 plus 3, which is 8. And then I get log base 2 of 32 times 8, which is what? Log base 2 of 256, which the answer to that is 8. So it shows that these work. So this says, what is the connection between the first and last columns? How could we skip the 2 steps in between? Well, you end up using this log law. It's called the multiplication law of logarithms. So if I have plus 1s in front and my bases are the same, I can put them together as multiplication as a single logarithm. Okay? So now we have to also remember that it works in both directions. So if I have 2 together by multiplication, I can also separate them into 2 separate logs. Not just 2 separate logs together as one log into 2. So the formula works both ways. So let's look at this one. For example, log base 2 of 15, 1 plus 1 log base 2 of 15 plus 1 log base 2 of y. Do you see that? They both have plus 1s in front. They're both base 2. So I can put them together as a single logarithm by doing what to them? Multiply. So we're going to get log base 2 of 15 times y. So it's just log base 2 of 15y, right? Then this one is log base 3 of 9xy. What people have to remember is, and this is what I always do every single time when I see this, log base 3 of 9 times x times y. I put the multiplication dots in there so I remember that I can separate them. Yeah? Bless you. So I'm going to get log base 3, guys, stop talking. Log base 3 of 9 plus log base 3 of x plus log base 3 of y. What is log base 3 of 9? What is the answer to this? 2, because 3 to the power of 2 is 9, right? So then I can write this out as 2 plus log base 3 of x plus log base 3 of y. Then we go to the next page. We have subtracting. What do you think is going to happen with subtraction? Division. Watch this, please. This has a plus 1 in front. Do you see that? So what's in behind it goes in the numerator, and a minus 1 in front, what's behind it goes in the denominator. Shh. So this could be out of order. They could have given this to me as negative log base 2 of 4 plus log base 2 of 8. It doesn't matter if they gave it to me out of order. Whatever has a minus 1 in front goes in the denominator, and plus 1 in front goes in the numerator. Okay? So I can rewrite this as log base 2, and the 8 goes in the numerator because there's a plus 1 in front. The 4 goes in the denominator because there's a minus 1. And so that gets me log base 2 of 2, which equals 1. You guys try 2, 3, 4. This would be log base 2 of 2 to the what is 32. 5 minus log base 2 of 2 is 1, so I would get 4. And then this has a plus 1 in front, this has a minus 1 in front, and they have to both be base 2. If one of them's like base 2 and one's base 3, there's nothing you can do, right? You can't put them together. So we get log base 2 of 32 in the numerator divided by 2 in the denominator equals log base 2 of 16, which equals 4. Then this one we'd have 2 to what power is 8? 3 minus 2 to what power is 16? 4. So we get negative 1. And so this has a plus 1 in front, minus 1 in front, base 2, base 2. So we get log base 2 of 8 divided by 16. Because 8 goes in the numerator with a plus 1 in front, and 16 goes in the denominator because that minus 1. It makes a difference. It has a minus 1 or a plus 1 in front. And then this will get you log base 2 to the half. 2 to what power gets me a half? Negative 1. Same answer. And then this one, 2 to log base 2 to the what is 32? 5. Log base 2 to the what is 8? 3. So I get an answer of 2. And so I get log base 2 of 32 divided by 8, which is log base 2 of 4. 2 to the what power is 4? 2.
So you know, just keep it as 8 over 16, so you have C.
You could not simplify in all of them, but then you'd have to do that step in your brain in your head.
Okay.
We're also not going to just have numbers, we're going to have variables, so we're going to have to simplify them.
Okay.
Yeah. So this one here gives us the division one. It has a plus 1 in front that ends in the numerator, minus 1 in front ends in the denominator. Once again, it can go both directions. So we're doing another one. So we have log base 2 of 15 minus log base 2 of y, plus 1 in front, minus 1 in front, base 2, base 2. So I can put them together as a single log. Log base 2 of what? 15 over y. Yeah. Then this one, I have a 9 in the numerator and x in the denominator. Most people are really good with remembering you can put them together, but they're bad with remembering you can separate them. And this one's good to separate because 3 of the 9 is going to give me an actual answer. So I'm going to get positive 1, technically, log base, you don't have to show the plus 1, I'm doing this to prove a point. Positive 1, log base 3 of 9. Then minus 1, because it's over x, log base 3 of x. And the reason why we expand it is this log base 3 of 9 is an actual answer. What is log base 3 of 9? 2. minus log base 3 of x. That's the reason why you expand it. All right, flip over. Okay, there's also the power rule of logs. These all three are in a row. So here's multiplication rule, the division rule, power rule. Okay, I told you that you always have to have a plus or 1 or minus 1 in front. So if you have a number there, all you do is you take the number and you bring it up as an exponent. So the power rule, for example, if I had like 2 log base 6 of x, I wouldn't be able to do anything to even put it together with another base 6 because it has this 2 in front, correct? But what I can do is bring the 2 up as the exponent, and then this is a plus 1, and then I'd be able to put them together. Okay? Well, how does the power law work? So let's try this one out. So it's just laid out for you. So here it says log base 3. I'm showing you how this can also be written, guys, I'm showing you how this can also be written as the 5 in front, log base 3 of 2, right? Because that's essentially what I'm saying. I'm saying I can go from this to that, or I can go from that to that, correct? So I'm showing you how mathematically it actually works that works out. So if I take this log base 3 of 2 to the 5, if I take this, I could rewrite the 2 to the 5 out as 2 times 2 times 2 times 2 times 2. Technically, could I not? And then any logs that are multiplied, I can actually separate with plus 1s, right? So I get log base 3 of 2 plus log base 3 of 2 plus log base 3 of 2 plus log base 3 of 2. Now, how many log base 3 of 2s are there? There are 5 log base 3 of 2. So I went from this to that, correct? I went from having the exponent up to having the exponent in front and them being equivalent. All right. So therefore, log base 3 of 2 to the 5 is equivalent to 5 log base 3 of 2. And that rule is helpful for when we want to put logs together and they don't have plus 1s or minus 1s in front, they have numbers in front. I can take those numbers, I can raise them as the exponent, and then I can put them together. So let's look at this one. So for example, log base 3 of 9 to the 2, how else can I rewrite this? Where could this 2 go? In front. So I could write it as 2 log base 3 of 9. And then I could actually do the math in my head. What's going to be? 2 times what? 2, which is 4. Okay, B. How could I rewrite B? Yeah, log base 2 of a to the k. So this just goes over those log laws that we discussed. Peanut gallery. Back rows of peanut gallery. Full show. Definition of peanut gallery in the dictionary. The faces. All right. Let's look at these. We're going to evaluate them. So, square root of these, a lot of these have numbers in them, and you're like, I can just type them in my calculator. Cool. Till I don't give you ones with numbers, which is what the diploma does. So we're going to practice it the right way. So square root of 27, how could I rewrite that? 27 to the what? Grade 10. A half. So remember that whenever you have the square root of something, it's to the half, because remember the exponent on 27 is a 1, and you drop the index underneath. So it'd be 27 to the half. If it was a cube root, it'd be to the third. Yeah? And then what can I do with that half? I can drop it in front. Now, what a lot of people will tell me, the answer is, look, because it's common error, they'll tell me, oh, 3 to the 3 is 27, and then I raise that to the half and I get the answer. No. What you have to do is you have to take the half and drop it in front. So you get a half log base 3 of 27. And then I can do log base 3 of 27. I can't do log base 3 of 27 and then raise to the power of a half. I'd have to do the 27 to the half first and then do 3 of that. So it'd be 1/2. What's log base 3 of 27? 3. So it'll be 3. And a lot of people get confused when you multiply fractions where one's a full fraction and the other one isn't, so I'm going to put it over a 1. So my answer is 3 over 2. Okay, what's my problem with 2? There's a minus sign, that's not a problem. I could put minus. Don't have ones in front. Ooh, ah, ooh, ah, ooh. Yeah, not just a pretty face, Deal. Not just a pretty face. Okay, so we have base 2, base 2. Do you see that? When the bases are the same, it should scream, put me together. Like, I wish it did. I wish it screamed it at you, then you would know. Okay, the only way I can put it together, though, is if it has plus ones or minus ones in front, which currently it doesn't. How do I get those bad boys to move? Make them the exponent. We don't take the sign with, we just take the number. So we have log base 2 of 16 to the half minus log base 2 of 8 to the third. Do you see how I'm not taking the negative sign with? I'm just moving the number. Yes? You can take the negative sign with, but it's much more complex. All right. So now I have log base 2. What's 16 to the half? It's not 8. It's 4. Is anything to the power of a half is what? The square root of it, correct? So 16 to the half is 4, because 16 to the half is the same as writing square root of 16. Yes? Minus log base 2. What's 8 to the third? 2, because it's just the cube root of 8. Now is it in a form that I can put them together? Plus and minus 1's in front. So this is a plus 1 in front, minus 1 in front, base 2, base 2. So yes, I can put them together. So I get log base 2. What goes in the numerator?
4.
4. What goes in the denominator?
2.
So now I have log base 2 of 2. And what's that?
1, 4.
4. Nope, 1. You guys try 3 and 4. So, base 2, base 2, base 2, base 2 screens, put me together. Then, plus 1, plus 1, plus 2, negative 1, negative 1. Now screens put me together, correct? I need to have plus and minus 1's in front. So, I'm going to get log base 2. Anything with a plus 1 goes in the numerator, anything with a minus 1 goes in the denominator. So I'm going to get an x in the numerator, a 2x in the numerator, and then I'm going to multiply them. Then I have a minus 1 in front, so x squared goes in the denominator, times the minus 1 in front, y goes in the denominator. So I'm left with log base 2. In the numerator, I get 2x squared. In the denominator, I get x squared and y. Because these are monomials, those x squareds can cancel. Do you see that? So then you can be left with log base 2 of 2 over y. And this is the correct answer. But they could actually go further. So now that they put them together, the reason why they could separate these back out is I know it's going to be log base 2 of 2 minus log base 2 of y. And log base 2 of 2 is 1. So they could actually keep going. So now that they put them together and simplified it, they can expand it back out. And they do that when these numbers actually work together. So log base 2 of 2 has a plus 1 in front of the numerator, minus log base 2 of y. And then log base 2 of 2 is 1. So I get 1 minus log base 2 of y.
So you want to see that?
Yep. Because just because you got an answer doesn't mean it matches the multiple choice answer. That's the catch with logs and exponentials. You have to be able to move stuff around. Number 4, a lot of people will just give me an answer. You can't just give me an answer. We actually have to do math on it. So, base 2, base 2, base 2, base 2, plus 1, minus 1, minus 1, right? So that means I can put them together. So I'm going to get it as a single logarithm. I'm going to get log base 2. Anything with a plus 1 in front goes in the numerator. Anything with a minus 1 goes in the denominator. So plus 1, I get a 2 in the numerator. Plus 1, a 3 in the numerator. Multiply them. Minus 1, 6 in the denominator. Minus 1, 8 in the denominator. Multiply them. So I'm going to get log base 2 of 6 over 48. Can that reduce? Yeah, what does it become? What's the answer to log base 2 of 1/8? Yeah, because you say 2 to the power of what is 8? 3. So 2 to the power of what is 1 over 8? Negative 3. Number 5, when they don't have any bases, it doesn't screen put me together as much. So what I do is when they don't have bases, I go and put in base 10 so that it kind of screams more to me that I can put them together. Okay? The first one has a plus 1 in front, so I'm going to leave that. This one I have to move it up and move this up. So I'm going to get plus log base 10 of b cubed minus log base 10 of c to the half. Then because they're all base 10, I can put them together. So I get log base 10. In the numerator, I have an a. I have a b cubed. And in the denominator, I have a c to the half because it has a minus 1 in front. Does everyone see what I'm doing? Plus 1 in front, numerators. Minus 1 in front, denominator. Okay? They will write this differently. C to the half, they'll often write as what? Square root of c. So they won't write base 10, because they don't have to. And they'll go a b cubed over the square root of c. Remember, anything to the power of half is the same as the square root. Anything to the power of a third is the same as the cube root. We learned that in grade 10, rational exponents. Okay? This one, we get base 8, base 8, base 8, plus 1, minus 1, plus 1. So I can put them together. So I get log base 8. 16 goes in my numerator. 2 goes in my denominator because there's a plus or minus 1 in front. And 4 goes in my numerator. So now I'm going to get log base 8 of 64 over 2. Bless you. Which is 32. And what's that? And then it gives you a reminder of the rules again in case you forgot them. And then we're going to flip over. Three, 4. Down to the bottom of this page. Go, try them out. Okay. So this first one, we have to remember that we can separate it. And when I see the 5 and the 25, I know they can go together. I put a little dot in here so I remind myself if that's actually multiplication in between them. So I'm going to get log base 5 of 25 plus, because it's multiplication, log base 5 of m cubed. And then minus log base 5 of n, because it's in the denominator. Now, what is log base 5 of 25? 2. And then these ones have numbers in front, right? So they're taking these and dropping them in front. So I'm going to get plus 3 log base 5 of m.
You kidding me right now?
Minus log base 5 of n. Were you wrong? Just didn't want you to pick the most common error. Nope. Okay, this one, Quiet, please. We get log base A. If it was the square root, it would be to the half. If it's the third root, it'd be to the third. So if it's the B root, what is it to? 1 over B. And what's the answer when you get log base A to the 1 over B? No, it's not. So the common error is to just pick this part. But remember, if I gave you like log A to the 7, what would the answer be? 7, correct? Because you'd say A to what power gets me A to the 7. So you're saying A to what power gets me A to the 1 over B? 1 over B. Okay? All right. Base x, base x, base x. I can't put them together currently because they don't have plus or minus 1s in front. So I'm going to get log base x of 4 to the 3 plus log base x of 8 minus log base x of 16 to the quarter. 4 to the 3 equals log base x of 64 plus log base x of 8 minus log base x of 2. All right, then we're going to put them together. So we get equals log base x, anything with a plus 1 in front, numerator, anything with a minus 1 in front, denominator. So the plus 1 in front, so 64 is the numerator. Plus 1 in front, 8 is in the numerator. Minus 1 in front, 2 is in the denominator. 64 times 4 is what? Yeah. All right. This one, I can replace, I can replace log base A of 5s with 7. And I can replace log base A of 3s with 8. That's it. It has to be that exact picture. So for this one, I'm going to get multiplication dots, right? So here I'm going to get log base A of 75 plus log base A of A to the 2. What does this turn to? Log base A of A to the 2. That turns to a 2. And then, oh crap, I have a 75, but I need 5s and 3s instead. Is there any way I can turn 75 into 5s and 3s by multiplication? 75 into 5 and 3s by multiplication. 5 times 5 times 3? Yes. So we get log base A of 5 times 5 times 3. And some people might be like, well, why the heck are you doing 5s and 3s? Because I need log A of 5 and log A of 3. That's why I'm doing 5s and 3s. Because this can be separated by addition signs, right? I can get 3 separate logs now with the log base A of 5 times 5 times 3. This can be rewritten as log base A of 5 plus log base A of 5 plus log base A of 3 plus 2. Because when you have multiplication dots, you have to remember that you can separate them by addition. Single logarithms, right? Now I know what those stand for. Log base A of 5 can be replaced with a 7, and log base A of 3 can get replaced with a 8. So I'm going to get 7 plus 7 plus 8 plus 2 equals 24. Now these two logs in 5 don't screen put me together because they don't have bases. This is base 10 and this is base 10. So when I put the bases on, that helps me out. They both have plus 1s in front, so I can put them together. So I get log base 10. And then, because they have plus 1s in front, they both go in the numerator. I get an x and I get an x plus 4. And what do I do with those two things when I have more than one item?
Like times it.
So do I have to write the base 10?
No, but
No.
there's something.
Yeah. So I can go log base 10 of x squared plus 4x, which is actually the same as b. 6 is base 10 logs as well. But they're plus 1s and minus 1s, so I get log base 10 plus 1 in front, so x squared minus 4 goes in the numerator. Minus 1 in front, so x minus 2 goes in the denominator. And so I get log base 10 of x plus 2, x minus 2, bless you, over x minus 2. These cancel, and I'm left with log base 10, which you don't have to write, of x plus 2. That's your homework. Write it down.